We're going to go ahead and finish up lesson 64 now. So I'm going to start on page 333 with 64.3, which originally says y equals inverse tan of x over a. And so we'll rewrite that as the tan of y is equal to x over a. And we'll draw the triangle. So y is the angle, opposite over adjacent, which means that this is the square root of a squared plus x squared. Now we'll take the derivative of this equation right here. So that was tan y equals x over a. And the derivative of tan is secant squared y and then dy. And over here, from the other ones that we've done, we know that it's 1 over a dx. So we're solving for dy dx, so we divide by dx on both sides, which gives us secant squared y dy dx is equal to 1 over a. And then we divide by secant squared y on both sides. So we have dy dx is equal to 1 over a times 1 over secant squared y. But 1 over secant squared y is the same thing as cosine squared y. So 1 over a times cosine squared of y. And now if we go back to the triangle that we had, remember the triangle was like this. This was y. This is x, a. Square root of a squared plus x squared. So then we would have dy dx, or y prime, is equal to 1 over a times cosine squared would be adjacent over hypotenuse. So that would be a over the square root of a squared plus x squared. And that was cosine squared, so we have a square here. So that's just going to simplify. This would be 1 over a times a squared over a squared plus x squared. And then this a will cancel in here and just leave us with an a. So we'll end up with y prime is equal to a over a squared plus x squared. And remember, when we get ready to plug into these things, a is just a constant. X is a variable, but a is a constant, a number. All right, so let's try the last one of this kind. It says y is equal to inverse cosecant of x over a. And it does say that x over a has to be greater than 0. Just, let's see, it did that. Oh, no, it would do that on, secant if we were going to do that, but we're not doing secant. All right, so in other words, x over a has to be positive. Find dy dx. So the way that we're going to rewrite this, remember, is cosecant of y is equal to x over a. And then draw the triangle. So y is the angle. Cosecant is hypotenuse over opposite. So then hypotenuse opposite means this would be square root of x squared minus a squared. All right, so we'll take the differential of this equation. If you remember, differential of cosecant is minus cosecant y cotan of y dy, and that'll be equal to just the 1 over a dx. And again, we're solving for dy dx, so we're going to divide by dx on both sides. And so negative cosecant y, cotan y, dy dx is just equal to 1 over a. And then we want to get the dy dx by itself. So dy dx is equal to 1 over a times, and let's see, that'll be negative 1 over cosecant y, cotan y, because we're dividing by both of those. And then 1 over cosecant is sine, and 1 over cotan is tangent. So then we get dy dx is equal to negative 1 over a sine y tan y. And then we have to go back to the triangle that we just drew, which was y here, a and x, and then square root of x squared minus a squared. So if we're going to write this, then dy dx is equal to negative 1 over a times sine of y is a over x, and tangent of y is a over the square root of x squared minus a squared. So opposite over hypotenuse here, and then opposite over adjacent here. And if we simplify that, see, these a's will cancel. So we're going to end up with the negative and an a in the numerator over x times the square root of x squared minus a squared. All right? And then similarly, that was cosecant. If we did secant, you can probably guess the only difference would be that this would be a positive right here instead of a negative. All right. Bottom of page 334. The derivative of inverse sine, these are just things to memorize, is u over a. Remember, a is a constant. So inverse sine of u over a is equal to 1 over the square root of a squared minus u squared, and du dx, and then d dx of inverse tan of u over a is a over u squared plus a squared du dx. Okay, so those two are two that they suggest that you memorize. The other ones, not so much, because you can derive them like we just did. Those, there were 4 of them that we derived. But these you need to memorize. So the next problem is y is equal to inverse tan of cosine of x. And we're supposed to find dy dx. Well, look at the derivative of inverse tan, this one right here. And in this case, u would be cosine of x. There is no number, so a would be 1. So we're going to plug in those values. So dy dx is going to be equal to, a is 1, So 1 goes here over, u is cosine, so that would be cosine squared of x plus a squared is 1 squared, and then times du dx. So if you want to think of this as the chain rule, because this isn't just a u, it's cosine of x. So what is the derivative of cosine of x? It's negative sine x. So that has to be multiplied here. That's the du dx right here. So then that will simplify to minus sine of x over cosine squared of x plus 1. Okay, let's try another couple of these. The next one says y is equal to arc sine of 2x, and we're supposed to find y prime. Well, this is the sine, so I'm going to put here the formulas. The derivative of inverse sine u over a is equal to 1 over the square root of a squared minus u squared times du dx. Okay, so in this case, u is 2x and a would be 1. So here we'll get 1 over the square root of a is 1 minus, here's u is 2x, so 2x squared would be 4x squared, but then we have to multiply by du dx. So what is the derivative of du, or of this u right here? It's just 2. So we have to multiply that by 2, which simplifies to 2 over the square root of 1 minus 4x squared. So again, think of this right here as the chain rule. This right here is not just u, it's 2x. So we have to multiply by the derivative of that u, which becomes the 2. All right, let's try one more of these. It's a little bit different. This is the integral of 1 over 1 plus x squared dx. So we want to look for the answer to a derivative in this form right here. So this could be a over a squared plus x squared, or a over a plus x squared. So let's just look. What do we have? Let's see. Looks like it's the inverse tangent, isn't it? Because inverse tan was this. Oh, sorry. Not x. U over a is equal to a over u squared plus a squared du dx. Okay, well, a is 1, which matches up with a squared is also 1. So this would be, and then the u squared is x squared. So there's the du dx is just 1. There's nothing different. So the answer to this is just inverse tan of x, not u, because it had x's in there, plus c. So you can see where those 2 that they told us to memorize come in real handy. So make sure that you at least memorize those 2 forms of the derivatives of the inverse functions. All right, so make sure that you have this lesson, lesson 64, ready to turn in on Monday of next week. Have a great week. Don't forget to come to class on Thursday for the test, and I'll see you next Monday. Thank you.